Kia ora Year 12. This is question 5 from exercise 7a on binomial expansions by request from a couple of you. I think it's a really good question to choose for me to do because it's got lots of fiddly little binomial steps in it. This is exactly the kind of question you might get in the exam, and you have to be really fluent with these skills, otherwise you're either going to make a mistake or you're going to spend too long on it. Okay, so we need this to feel really, really easy. So the first thing we've got to do is a little bit of algebra. That's probably worth 1 mark. And then we're going to write down the first 3 terms in this binomial expansion. So the first 3 terms means we're going to have a 1 plus a something x plus a something x squared, right? So this is my basic form of the binomial theorem for negative and fractional powers. Then we have to say when this is going to converge, right? So this is for the case of 1 plus x to the power of n. Our job whenever we do one of these is to force what we're working with into this pattern, okay? And then once we've done that, we're going to be able to say that this building block here of x has got to satisfy this condition, that the absolute value of x has to be less than 1. In other words, unless x is little, this series won't converge, alright? So the expansion's not valid. So that's what the condition for validity always comes down to. The difference is that we won't be working with an x here, we're going to have something else. It might be negative something something. Okay, right, so let's get going. First we have to do that with a little bit of algebra, and then we do the binomial expansion. So we rewrite this with a fractional power, and now we force in a factor of 1 in here, as follows, right? So we get this 1 in here, and we bring the 4 out here. And that equals 4 to the power of negative a half times 1 minus x on 4 to the power of negative a half, which gives me 1 half times this. Okay, so we're done as required. The next thing we're asked to do is to write down the first 3 terms in the binomial expansion of this. Right, so notice that we're not working with the 1/2 part at the moment. We're working with just the simple binomial expansion. Let's clean some of this up. Right, so we've got 1 minus x on 4 to the power of negative a half. So n's equal to negative a half, but we have to just change this a little bit. So this equals 1 plus negative x on 4 to the power of negative a half, which equals 1 plus n x. Right, but it's not x, it's this building block here, plus n times n take away 1 divided by 2 factorial, which is of course just 2, and then my building block thing here squared. Right, now I'm going to make that and is approximately equal to, because I'm just working with the first 3 terms. And we can expand that out, and we get 1 plus 1/8 x plus, carefully here, I'm going to do this in 2 steps, 3/8 times x squared on 16. Okay, so that's the first 3 terms, and now we have to say when is it valid. Well, we're working with this expression. So it's valid when the absolute value of negative x on 4 is less than 1. So the absolute value of negative x on 4 is the same as the absolute value of x on 4, which is the same as the absolute value of x divided by 4. So our condition is the absolute value of x is less than 4. Right, so that's the first couple of bits done. So what's the last thing? Well, this looks really bad, but it's not. Okay, so in the last step, what we have to do is find the first 3 terms in the expansion of this. But we know that this bit here corresponds to 1/2 times the stuff that we just did. So we're going to write this out really slowly so that we don't miss anything. So we've got 2 times 1 plus x over the square root of 4 minus x. And that equals to 2 times 1 plus x times 1/2 times that. Just going to change pen colour for George. George, hope you're happy. And now I've got 1 plus x times this. But we already know what this is from my binomial expansion. So just taking a little bit more space. No, that's not going to work. We've got this. So it's 1 plus x times what we had before. 1 minus 1/2 x plus 3 over 128 x squared. Now I want to show you how I set these out because I think it can make it much easier not to muck it up. Right, so first multiplying the 1 through by all of this and putting it in place value, I get 1 minus 1/2 x plus 3 over 128 x squared. And then I'm going to do the same thing here. I'm going to have x times each of these. Now we're just asked for the first 3 terms, I think, so we don't have to take this fully through, but we get plus x here minus 1/2 x squared, right, for that bit. And then we'd have plus 3 over 128 x cubed. But we're probably not going to bother with that because that would be a 4th term. And then we add this up. And it makes it very easy. Well, I reckon it makes it very easy if you do it in place value columns. So we get 1 plus 1/2 x. And now this is a pain, right? So I know you're going to use your calculators. That's okay. But I'm going to do it the proper way. So we get 3 over 128 minus 1/2 is 64 over 128. X squared dot dot dot, which gives me 1 plus 1/2 x minus 61 over 128 x squared. Okay, so there you go. That's that question 5 done. Hopefully that helped, and email me or let me know if there's any other questions like that you'd like me to whoosh a video up of. Have a good weekend.